Okay, thank you very much. And it's really a pleasure to be here with such a wonderful panel and talking about a quite transversal topic, apparently, because all the other panels were mentioning scientific computing, advanced computing. So let's see what we can add with respect to that. I think it's obvious by now that advanced computing applies to a myriad of different contexts. And now we basically want to discuss the future. So we could talk for hours about what was done within the scope of the program. And there's obviously, everyone is very proud of Deucalion, which was recently inaugurated. But what I propose to my fellow colleagues in the panel is that we focus on the future. And actually, I think the title of the conference is perfect for us, because it's about the future and about modeling. So we literally do it in advanced computing. So let's focus on the different applications, on the bridge between academia and industry. How can we build one or more bridges, and how can we do this crossing together, and how we can collaborate. I don't want to close the discussion in terms of topics, but I think there are obvious points that at some point we might want to discuss, such as new paradigms of computing, emerging areas, both from the academia and the industrial side, which can benefit from computing, either the computation we are doing these days or eventually the computation of the future, whatever it is. We should also discuss the role of Portuguese infrastructures in advanced computing. I'm talking obviously about Deucalion and about MAC, but also about the different networks and the different infrastructures, the different kinds of services that we have. So I'm thinking about, of course, high-performance computing, but also high-throughput computing, distributed computing, new kinds. How can we benefit from new architectures, new processors, and eventually even from quantum computing? And I would propose that we also touch these points. Another important aspect, I would say, that it's this relation with industry, and how can advanced computing be a leverage for innovation? How can we contribute as an area for innovation, and in particular for fostering the innovation in Portugal with the very specific context of Portugal, and how these international collaborations can help in this context. And lastly, but not the least, and again, these are just my thoughts, but I will shut up, and it's really up to you to discuss it. It's the advanced training, the training both for the infrastructures themselves, and we need to make sure that to train and to retain at least partially the teams, but equally or even more important is to train the users, to train the current users and eventually the users who don't yet know that they will profit from advanced computing. How can we engage them? How can we train them? How can we do this path together? So before we go around, I believe that the technical team can project a very open question for everyone. Yes. So what we propose is that during the session, you can basically mention the areas which you believe that can benefit the most from advanced computing. So that should help us to form a cloud of words, and I'm sure that our panelists will pick up on that and eventually comment. In terms of organization, what I propose is that we go a first round, and I will try to propose a question for each of you. But please, let's keep this informal. So at any point, if you want to comment on a previous answer, if you want to bring a new topic, feel free to do so. This should be really a conversation and not something too guided, in my opinion. But okay. since we have to start somewhere, maybe I would propose that we start with Dan, and I would ask you, what is the importance of international collaborations and networks for advanced computing in Portugal? What is this role?
Yeah, there's a lot of different aspects to that, ranging from, no? Better? Okay. So, advanced technology, it's a challenge. There's several different aspects to that, right? I think, in the past, the collaboration, as much as we've built great computers through this, it's the people that have been the most important part of what we've done. And, starting many years ago with the student exchange programs, I think the exchanges have been enormously valuable through the years. And in fact, some of the bigger projects we work on now are people who've come through the exchanges. Zhao started, is Zhao still in the room? Barbosa, who started, who's sort of managing operations at Mac now, started as a graduate student like 15 years ago through this program, and then actually came and worked for us for a while and has now come back home to Portugal to run the infrastructure. The people part of this has been super important through the years. I think it's only going to be more so moving forward, and because of the thing that is popping up in the center of the slide as the biggest name, and will continue to pop up, probably get bigger, is AI, right? And so there is, in the last panel, Paolo posed the question of how many of you are hiring AI people, to which I was sitting with my colleagues in the audience and said, good luck hiring AI people in other scientific domains, because, if you're a new PhD in AI out of Stanford, probably your starting salary is in the $500,000 to $700,000 range. And if you have experience, it might be, real money. So the demand is astronomical. And AI and HPC infrastructure are essentially the same. And, generative AI with the start of the Transformers model about 5 years ago have made these huge scalable infrastructures critical for AI and for HPC, right? Really removed any sort of difference in the way we deploy infrastructure. But that means the people who run these, the people who know how to use them, the people who know how to exploit the hardware, there's enormous demand for people who are trained to do that. And it can be people exploiting AI hardware in the sciences, either through how to do reduced precision algorithms, or how to do bring surrogate models from AI into the scientific workflow. It can be the other direction, right? Everything we know about advanced networking and for large-scale language models at the moment, that's all MPI-based and using InfiniBand for the most part, all technologies that grew out of academic HPC over the decades. So, and I think if you look at, little known fact in AI, as more and more topics pop up on the screen here, right now, if you buy a GPU, if you buy the old PCI card GPU, it's only about half the price per ounce of gold. But if you buy just the socketed GPUs, they're about 5 times more expensive than gold. So I could redeploy our data center as racks of gold bars, and I'd have a lower power bill and lower capital investment and not as much depreciation. I'd be terrible at computing, but it would literally be cheaper to put racks of gold bars in than what we actually deploy at the moment to do AI. But they're used horribly. The efficiency of how they use those, it's just terrible. And it's because AI doesn't necessarily come from the scientific computing background, where we understand that if you're multiplying a lot of zeros, you might want to use a sparse matrix format, or it's just straight gradient descent. So there's a huge amount we know in numerical methods that I think could still benefit this multi-trillion-dollar industry that is AI. So, and for things like reduced precision or improving efficiency, you don't have to have $100 million in infrastructure to work on those problems, right? It's small teams can make huge differences. There's a company, Hugging Face, which does training. If you want to do a 70 billion parameter model training right now, which is small compared to GPT-5, it costs $15 million to train the one model in cloud time, right? So not a lot of people are going to be training big generative models. It's actually one of our big problems in the field, is that you have a $15 or $20 million entry point to do one model. So we can't have grad students necessarily doing that. But if you want to figure out how to use that hardware to get another 10% and save $2 million per model, that could be how we do reduced precision, right? Which is something we can train a lot of people to do pretty easily. and you can work on without this infrastructure. So I think, one, we need all the people we can get everywhere in the world to do it. And two, there's a ton of things you can do without this massive infrastructure, although I'm a big believer in massive infrastructure, but there's a ton of ways we can train people to exploit AI hardware, both to do scientific computing and to provide the workforce for AI.
Thank you very much. You touched a point which was raised in the first panel, I believe, about the clean energy and about whether there's a dichotomy between AI or advanced computing, and eventually we don't even need complicated models for forecast, because we can train an AI and have it in real time. Eventually, yes, but as you mentioned, there's also this point of using it effectively, because in the end, it's always computing. And if I want to be provocative, I could mention that there's no point in investing in green sources of energy to provide power to these computing centers and then waste all the gain in inefficient AI models or any other computing models.
Sure. Yeah, and to put another number from today in the energy panel was that the peak demand on the Portuguese grid is 7 gigawatts. The estimated spend next year in AI hardware is $300 billion worldwide. That will require 38 gigawatts of data center to build. So we have to add on to the existing data centers in the world roughly 6 Portugals of power just to support AI, right, in computing. So yeah, and if we could get, well, I think we can get 1,000% improvement in the way that we're training it from software inefficiency at the moment. But if you could get 10%, that's half of Portugal's total power footprint saved if we could just improve AI training by 10% from efficiency. So better trained people to do that, going to be huge. Yeah.
Training again. So maybe we now can continue on the international collaboration, but at a more Iberic level. And I would invite you, Lois, to comment on the possible relations and what can we mutually gain from by exploring common infrastructures in Portugal and in Spain, in Galicia. I'm thinking, of course, about Mare Nostrum, but also in Sesga, the new quantum computer. How can we benefit from this, and how can we be stronger by joining efforts?
Yeah, so yeah, I agree with that collaboration is fundamental in the research we do today, right? Both because of multidisciplinary research, doing research between different disciplines, so the result will be more impactful, but also between different countries, because we have different cultures and we can join forces together to do something better, right? So it's the case with, I think, with Galicia in our case and Portugal. Actually, I am happy to be here because I already have a lot of conversations and possible collaborations and conversations, and this is very cool. And it's curious because this is an international collaboration, but I came here by car, so two hours ride from Sesga to here. So this is also a huge advantage, right? So, for example, if you want to collaborate in a European project, we could be still different countries, but we are neighbors, so we are, we can meet in person and very frequently. So, yeah, the opportunities, actually, Galicia and Portugal, they have some collaborations in the past, right? And some projects that I have here are, for example, Evergrid, that is on distributed computing, OpenPhone. There is a good data network between Vigo and Braga, I think, or Guimarães. Yeah. Yeah, some things have been done in the past, but I think much more things could be done in the future. Something that could do for improving this collaboration is what we are doing right now, right? So coming here, invite you to come to our facilities, collaborate, talk, and be aware of what you are doing and what you have. And I think this is common because of the conversations that I have until now, that we are all very open to collaborate because I think it's beneficial for all of us, right? So what else? So we, as CESGA, we are a supercomputing center. We was born in 1993, and since then we were collaborating with. Our philosophy is collaborating. We don't belong to the universities, but we have projects with all Galician universities. We have projects with national institutions, with European institutions. So this is in our blood. And I feel that we don't have such a strong collaboration with Portugal, and I would like to make it strong with meetings like this, right? Yeah, so most important is find synergies, sorry. So because if we sign a paper saying we are going to collaborate, but there is nothing behind it, it doesn't worth it, right? So first thing is researchers to talk and find good projects. And then, let's see. I think that from the political side, many things can be done, agreements, etc. This center is, I think is part Spanish, part Portuguese. This is already something, right? But from Galicia and Portugal, Portugal is very close to my heart because it's culturally we are very close. So we should do it. We should be very close also in the research part and in sharing infrastructures. We have the Finisterre 3 supercomputer that is less powerful than the Deucalion. I think it's half the powerful. It's 4 petaflops peak, but a little bit different configuration. So we can, have some maybe agreements on sharing or whatever. It's a matter of sharing what we have and what we need, the projects that we want to run on these infrastructures, and maybe we can find some synergies to share these infrastructures. And we have a quantum computer that is a 32 bits quantum computer that we just inaugurated like a couple of weeks ago. I know that here there are a lot of good people working on quantum, so we are already having conversations with them. As always, the difficult part here is people working on projects, hiring people, competing with companies. So they do research in public institutions like ours. And for me, that's the big challenge, right? Finding people to work on nice projects and using these infrastructures. Yeah.
Okay, thanks a lot. So now we have heard the perspective from two directors of two super advanced computer centers, both at Texas and Galicia. Let's try to see it from another perspective. So if we look at our public, we discussed AI, but if we see the others, we have a few related to government and public policies, but lots of them. So energy management, medical devices, supply chain optimization, all of these points to innovation and to companies and to industry. So Sylvia, how can we see it from that perspective as well? So how can the private sector, how can the corporate sector benefit from advanced computing, and how this sector looks at these kind of opportunities, at these kind of infrastructures, and can these infrastructures be useful, and if yes, how?
Okay, first of all, thank you for invitation. I'm very grateful to be here and to share my point of view. Just let's to the beginning, which is most of the supercomputing, advanced computing, I imagine, and the panel talk about it, is, I believe, this is almost in the scientific proposals. So the challenge is, are we going to put companies use advanced computing? Do they understand advanced computing? do they really need advanced computer? So this is the basic question. Okay. So I think this is a challenge for scientists, but it's also a challenge for companies. Do they want to continue to use the conventional computing? Probably they do. Probably they won't need supercomputer for all the business proposals, for all the solving problems they have regarding engineering. But the other question for companies is they really want to continue to do what they are doing, or they want to innovate. But because if they want to innovate, they have to go forward. They want to be the forefront, yes, so they really need to step up. And how they do that? And supercomputing could be a very useful tool for that. But there are another challenges. Well, we have a lot of applications here, and most of these applications are related with deep tech. And the deep tech really understands, most of the deep tech really understands supercomputing. But do they have enough money to affordable? Because cost is another problem. And the infrastructure, they could solve this problem because the commercial platforms like Google, AWS, they offer these tools, but they are very, very expensive. For a startup, for instance, it's completely imagined to afford this kind of cost. And even the big companies, they have other challenge to manage. For instance, do they regarding the infrastructure, do they need, or do they have to overcome? Do they really need to overcome the interoperation to the legacy infrastructure they have? How are they going to face it? The compliance as well. We already talked in some other panels. The privacy, the data privacy. Another aspect. Do they have enough data? Because supercomputing is only need. Well, it's not only need, but most of the reason for supercomputing is related with large amounts of data and analysis of it, the big data. Do they have? Do they need? Well, this is all the answers that the companies need to be aware of it. And my answer is most of the time, yes, but they don't know. And the other challenge that the company and it's not only the companies, but the companies have a huge challenge is the human resources. Do they have enough skills, enough capabilities, resources, persons to deal with supercomputing, with advanced computing? Well, this is all questions that we need to address, to innovate, and to go to the next stage. And yes, do I have answer? Well, my answer for this is the collaboration between academy, between the centers, between the interface system, and also the educational system as a huge challenge as well, which is do we really does the classic courses prepare people for this kind of challenge for the future? Now, this is a question.
Very well. And also one point we were discussing over the break was the continuity in time right? Because it's also important to give some guarantees to companies that they will have a good solution and it will be supported for 5 years, 10 years. Otherwise, there's no point, right? It's too risky to move everything to find a great solution, but eventually, after 1 year, no one can use it anymore. So it's also another challenge.
Another challenge, the maintenance.
Yeah.
Okay, first of all, you need to deliver a product, not a prototype. And even if you deliver a product or service, does the company has the skills or affordable the maintenance of all this service of this infrastructure? Yeah, this is the question.
Skills training.
Skills training.
That brings us to Miguel. And so Miguel, how can we train people? How can this kind of programs can help to train people? And again, I'm talking about the users we have, but mostly the users we don't yet have. So how can we train them? How can we attract them and at the same way help them to help us to give support and to give training so that these infrastructures can be used beyond the typical uses which have been used so far. So, of course, we know that many different scientific fields are using since decades advanced computing. Some companies, mostly big companies, but some smaller companies as well. But how can we enlarge this? How can we have a joint training scheme so that we can have more users and more informed users?
So, first of all, thank you also for the invitation and for the possibility to share my experience with this audience and the panel. Thank you, Sylvia, for raising the point. It was quite clear what you mentioned and the reason associated to the need of training. If we don't have that clue, we just have to look also to the board. There are so many topics that can benefit from advancing computing that it's obvious the need of training. Training is mandatory. Training at different levels, as you mentioned, Nuno. Training to the persons that operate the hardware that is continuously evolving. And I've been working in the field of advancing computing for more than 10 years. I always feel ignorant. Every time I'm faced with a new system, there is the need to learn. And learning is a difficult process if you don't have partners. If you join with someone that knows how to do it, with whom you can share experiences, you can share your needs. This is quite important and really facilitates the process of learning, of sharing information. Because, for instance, a computer scientist knows very well how to operate the system, but he might not know the needs, what has to be solved, which are the problems, how the problems are usually solved by someone, by a physicist. And by joining efforts, by exchanging experiences, this could be the secret to progress much faster. Along the day, we have heard several times about the importance of people. Dan mentioned that when he spoke about the cooperation. People are mandatory. People are the key of success of these initiatives. So if we train the people, if we teach them, and teach means sharing information, because when you join a team or a group like this one, you are not going there just for learning. you are also going there to teach, to share your information, share your needs. And when you share your needs, you are teaching someone something he doesn't know, and it will facilitate the way it can help you. So obviously the answer to your question is obviously it's mandatory to have advanced training. And training, I would also translate it as or using a synonym as sharing, and sharing different experiences. This is very important. Regarding the problem of reaching industry, from the experience I have with working with industry, large companies, they use it on a daily basis. They know the advantages. SMEs, that in many cases that's the difficulty, and they are used to work in a certain way. They have profit from doing it in a certain way, and reaching them and showing them the availability or the possibilities of using advanced computing is always a challenge. And Sylvia mentioned the cost. Cost is always a problem. Obviously, it's a problem for any company. The cost, when you see numbers, big numbers, and you start making some calculations, the first answer is that no, we won't do it. But let me share with you the recent experience we had in the framework of the project FF for EuroHPC. And I was involved in one of the experiences, one of the experiments, sorry, and we, together with the company, we understood their challenge. We tried to come up with a solution, and at the beginning, there were no solutions, no obvious solutions for the problem. But at the end, we came up with a solution which, even by using, resorting to HPC, to high performance computing, the cost, the amount of cost related to the computing was very small when compared with the cost they have in terms of development. Mm-hmm. And it was, at the end, it was easy for them to see that there is a clear benefit from resorting to this. One of the problems that Sylvia mentioned at the end is, okay, people. How can we have people that is able to take advantage of all these systems? And it's training. Training, I would say, again, sharing experiences, and try to learn from each other what they know and be able to progress faster together.
And eventually related to this, one word we heard a lot during the morning session and during the introduction was that we need trust. People need to trust each other. There's no collaboration without trust. So how these programs such as UTIOS in Portugal can help to build this trust between different communities which a priori does not necessarily know each other. So how do you think this can help?
We are obviously, if you're not are motivated to get together, to work together, our first option would be to let me try to solve the problem. And from my experience, what I would say is that if we have cases, successful case studies, where we show the persons which are the benefits of working together, of sharing experiences, this is the easiest way to motivate persons to do it, to share. And share means share the problems, because if I don't know exactly which is the problem I have to solve, for me it's difficult to come up with a solution. I can try to do it in a certain way, but at the end, that's not the problem. That's not the exact problem that has to be solved, because there is something else. And if you allow me, I can also share a recent experience I had with a company from the shoe industry in Portugal. We have, in the framework of a project financed from an innovation agency, that there was a problem of injection of polyurethane with shoe soles, and so I start making the plan, and I come up with a solution to have a code that was able to model the full process, the expansion, the chemistry, all the stuff. And at the end, I visit the company and I propose them the solution, and then they told me, okay, this doesn't seem to be related with our problem. And then I went to the machine, and it was completely different. What they're facing is something at the beginning of the process. It was polyurethane injection, but not even related to expansion. So the solution was even much simpler than the one I thought at the beginning. And I managed to figure out which was the problem by sharing, because they shared in detail the problem they had. So I agree with you. They must, the companies must share. Sometimes it's difficult because they want to keep it as their own knowledge or their own secret. They don't want to share their limitations. But if they envisage some benefit, they will do it. They will do it, and at the end, the results are very useful for everyone involved.
I love the topic, so I can ask questions forever for my own benefit, but to try to make it a bit more distributed, I would like to invite any of you, to comment on any of the points mentioned so far. Would you like to add something?
Sure. You should know better than to give us such an open-ended invitation, Nuno, to comment. So we'll all comment for the rest of the day if you give us the opportunity. But but in terms of this industrial usage of HPC, so first of all, in the Fortune 500, the large companies, right? There's a huge amount of usage, and some of them are the companies you might expect. The biggest HPC spend is Boeing, right? So up and down the airframe. Making large jets, there's tons of HPC work. But one of the bigger ones you probably don't expect, the oil and gas guys are all there, seismic wave inversion, they're among the top, Caterpillar for engine design and things like that. But Procter & Gamble has historically been one of the biggest spenders, right, who makes consumer products from, potato chips to diapers. So I guess they cover all ends of the digestive tract. But and one of their original problems was, if you've ever had Pringles potato chips, they're basically shaped like an airfoil, and you can only speed up the production line so fast before they become airborne. And to increase the production rate, they had to do a huge amount of fluid dynamics modeling and CFD-related work. But the materials to keep diapers from leaking, the shape of your toothbrush and putting the minimum amount of material into that, all hugely computational, and they made vast investments. And so, for within, say, oil and gas, it's make a big investment in HPC and keep it in-house and protect your data. And that's the traditional model, right? Because no one wants to share their seismic wave inversion models because they determine, should I bid 10 billion or 12 billion for this lease to develop a piece of land, right, to pull out natural gas today. And they, that's not going to the public cloud. On the other hand, there's the AI startups that consume computing in a lot of different ways. But very different than the traditional ones, where it's smaller companies. And first of all, there are some building their own infrastructure, and it's like nothing I've ever seen, right? The reason GPUs cost 5 times as much per ounce as gold is there are companies who pre-market, pre-competitive, right? get $1 billion in venture capital to buy hardware. I know of at least 3 this year, between $600 million and $1 billion in hardware investment, just to train the product that they will eventually have. Right? And they're buying all the hardware on venture dollars. And I've never seen venture capitalists who were that gullible before. So but a lot of them are using cloud resources and other resources, and they don't necessarily need to co-locate with that, right? So there are small companies who use our infrastructure, Spark Cognition in Austin, who's grown from, I think, 20 people to 300 people in the 2 years that we've worked with them. Come to us to get fractional infrastructure and just pay us for it to do it. There's companies that do infrastructure in the cloud, but then locate their people where the people are most effective. Define.ai, which was founded by a woman, Daniela Braga, is the CEO. She was a Portuguese citizen, but lives in the US. And she founded the company in Seattle. But in Seattle, you sit between the headquarters of Amazon, Microsoft, and Boeing. So to hire AI people, the R&D center is in Lisbon, where she's hiring up staff because she can afford staff in Lisbon. And all of their infrastructure is a virtual overlay on cloud computing to do that. So we're seeing where they need this sort of fractional time instead of dedicated hardware, right? They're living with cloud providers or coming to large centers to engage in how to get the compute time and the expertise, right? We had to build a custom interface for Spark. I mean, they were AI algorithm experts, but they knew nothing about using big systems. And we ended up doing a little customization work so they can use their Microsoft development environment that they're used to dispatch jobs to our machines. But yeah, I think, so usage is historically large. The majority of HPC spend is in the private sector. But again, the HPC hardware market is 10 billion. The AI one is 300 billion. So there's this explosion of it now. And companies, there's about 400 versions of this joke at this point, because you can insert the profession or kind of company here, right? And it's, people ask, is AI going to destroy X, right? Sometimes that's society, but usually a profession. But will AI destroy all the companies? No, but companies that use AI will destroy companies that don't use AI, right? Is likely true. So I think the adoption of some form of advanced computing infrastructure is going to be pretty much ubiquitous across industry. And the demands for people who can do it and the skill sets will be about the same.
Let me go a bit deeper on one point that you mentioned. You gave this example of companies which have models which took fortunes to develop, and they don't necessarily want to have it on the cloud and lose control of it, so they prefer this kind of infrastructures. So can we look at advanced computing infrastructures such as DAC, MAC, as also as a strategic tool for the companies in order not to depend on other companies, which sometimes can even be competition. So.
Yeah, and actually part of that competition is just being neutral arbiters for open data sets is a huge piece of it, right? So you can train some of these models, but I think two sort of subpoints on that. One, yes, and in fact, I was on a committee over the past couple of years where we're designing the U.S. national AI research infrastructure. And democratization of that infrastructure is a major goal, right? Because, again, if you're working on a trillion parameter model, you work at, I didn't do it, at Google or Amazon or for the Chinese Academy of Sciences. There's a very small set of places you can work and work with trillion parameter models, right? So, and making that access more broadly accessible is one of the big reasons for public investment, in these kinds of infrastructures. But the other thing is when you look at like the OpenAI model, where they sell by hits against their model, and you can tokenize your data and put it on top of that model. They really sell by token access. But and so this notion of consuming advanced computing as services, right, where perhaps what we have is a large language model living on our infrastructure, and instead of coming to the computer center to get an allocation of hours to run your CFD code, which is what we traditionally do, here's 1 million hours to go run your simulation, it may be, I need 50,000 API hits against this service to build this higher level service that I'm putting out there in the AI space, right? To take your base language model and make it answer specific questions about, I don't know, carpentry, pick a topic. So I think, this sort of fractional consumption of it in sort of a cloud style may be a thing that spreads the infrastructure more broadly. We have a few big shared infrastructures, and companies can build on that without having to replicate how to run all that infrastructure, right? Either through public labs or through the Googles and Amazons and Microsofts of the world.
Thank you very much. I think we should go to the audience really soon, but before that, any follow-up, any comments any of you would like to do?
I just want to to point out one issue, which is related with energy. Well, energy management is one of the major applications regarding our survey, but the supercomputing, advanced computing, is itself a problem to energy. I don't know if you,
we're the cause of and solution to climate change.
Can talk about it.
Yeah, well, you want to take a shot at that first? Yeah, I mean, we are a huge energy user, and there's a lot we can do to be more efficient about it. Part of it is, we can shift time for peak power, and efficiency is just a huge driver, especially in the AI space, right? It's always been in the HPC space because we had no way to pay for it to get what we wanted done. In the AI space, because the money has been infinite from venture capitalists, nobody's worried that much about efficiency yet, so that's why I think there's so much space to do things there. And, like I said, if you're a grad student in the audience and you can, if you can improve the efficiency of AI training algorithms by 10% and publish a paper on it, well, ideally you'd sell it to somebody. But if you published a paper on it, it was adopted the way TensorFlow or Torch has been, you could do more, you could decarbonize more than the equivalent of moving all of Portugal to renewables. And you can do that in one software product. And there's not very many opportunities in grad school to have one person have that kind of impact. But yeah, I think, there's so much we can do in energy management at the hardware level. But I think the topic here is probably in the notion of smart grids and modeling. But it is ironic that, HPC is key to doing the climate models. It's key to doing the smart grid, CFD for turbine placement for renewables, materials for PV. But at the same time, we're eating all that power that is being produced. So yeah, we are the cause of and solution to the problem here.
We need green infrastructures, but also green code. So
yeah. Need that green hydrogen.
Yeah, just a couple of points. So in this HPC, I just want to point out it's not only important for companies, but also for public institutions, because we are generating a lot of data, like, for example, in hospitals, genetic analysis, this type of stuff. So this is not only a matter of companies, but also of public institutions.
Government and public policy. It's one of the...
Oh, it's there. Okay, yeah. And regarding, energy consumption, that's super important, and this issue is going to be worse and worse with time. So that's why it's so important to invest in research on new technologies and new devices that consume much less energy. Like, quantum is one example, but we are very far from doing something in production, let's say, with quantum, but we have to invest on this type of research as well, because this is becoming a huge problem.
Yeah, obviously hardware is also one of the possibilities, but software also. The codes we develop, the codes that were developed by humans, they have errors that can be improved, and again, knowledge could help that a lot. And I've seen codes I've been using that have got a lot of improvements that reduce significantly the calculation time. And for instance, knowing the problems we are solving is also some of the key details of success, because sometimes we don't need to reach such a precision to get the solution. There is an amount of calculation we have to reach a certain level, and that would help us saving calculation time. And even not improving the hardware, we are saving energy by doing that. So this is one of the possibilities.
You're totally right, and I'm sure that if you look at all the programs that are running in our supercomputer, many of them will be super inefficient. So that is something that it has to be with education.
Again, is advanced training.
Again, training. Eventually, it's time to mention the role of these competence centers in EuroHPCs. So we need to capacitate the users, and we need competence centers for this. We need to spread this as much as possible for the different communities. Okay, as you saw, we can go on forever, but I think it's good now to give audience the opportunity to make any comments, questions, whatever you might have. Feel free to elaborate on some of these use cases that you mentioned, if you would like to.
It's a shame you don't see any applications.
Okay, so doesn't seem to be the case. So I invite my fellow panelists for a final remark, a short remark by each of you, maybe? Miguel?
So I'd stress again what I mentioned during the topics I refer to. It's the need of sharing. I believe it's not just training. The important it's to be able to share knowledge, work together, and at the end we all benefit from that. And sometimes you find that those difficulties in companies as well. But at the end, if they share, they don't have to share all the details of the knowledge. But if they share, if they find a solution for their problems, that will benefit everyone. So what we should do together is work together, join efforts to solve more complex problems more efficiently. And at the end, we'll save energy and we'll reach to the solutions we need.
Yeah, those are great comments, Miguel. And echo your first comment about people and collaboration, right? And that's where I started, right? And I still think, the primary value of these kind of long-term partnerships is the opportunity to build steadily more meaningful collaborations as people sort of grow up in the project and become more senior, and we get to know each other better. I think with each round, we've had more in-depth collaborations, and in the case of now TAC and MAC, right, there's been such an obvious sort of feedback loop there, right, where you can see the capacity growing here in response to the investments we've made, and we've benefited enormously from having all the people come over because, as you mentioned, hiring is always the #1 challenge, right, and the chance to develop new students and do those things. The collaboration's been really, really impactful. And the other thing, as we talk about opportunity in advanced computing, AI is the opportunity, but it's also the threat, where it's sucking up all the air in the room, all the people, all of the hardware capacity. It's driving up costs for anything and protecting that role of high energy physics or fluid dynamics and the traditional scientific computing could be awash in AI, right? And AI-specific hardware. And we're going to have to continue to invest, not just riding the coattails of AI, but in protecting that unique role of computing for scientific discovery. So moving forward.
Yeah, I agree with your comments. Just want to emphasize that, computing in general will become more and more important with the years, because this is not slowing down. So it's super important to do research, to train people. It's super important to collaborate, especially for me, I think, multidisciplinary collaboration, computer scientists with physicists and biologists, etc. So you can get the most out of our algorithms. on our infrastructure, so we can do these advances with consuming less resources, right? So yeah, basically.
Sylvia.
Just to pointing out and sum up some of our comments. Yes, I truly believe that advanced computing, AI, will be the driver of innovation of the future. And I truly believe that it could solve some our complex problems and the global challenge that we all face it. And yeah, I think this through collaboration, through sharing, through training, to enable the system to go to this to go forward, to drive to this goal, that we can move forward and face the future.
Thank you very much. I think we can close this third panel with. I would like just to leave the challenge, the obvious challenge. We have now lots of opportunities in terms of the new machines which are getting ready. We have the new ones, the pre-exascale and the exascale ones, and it's up to us to benefit from it, to keep in mind that probably it's not very good idea to put all the bets on the same side, whether AI, HPC, or whatever. Keep in mind that we can learn a lot from each other, and the only reason for the existence of these infrastructures are the users. So we need to continue to train users, to expand users, and to reach more and more users, both on the academic side and in the industry side. So this is the challenge for all of us, I would say. And I think that with that we can conclude this panel. And thank you all very much for accepting and for this lovely discussion, at least from my point of view. Thank you.